Victor and a few of. Yeah, had a good time. So yeah, it was good. So look, I thought I spoke to Victor then and said, look, I'd love to do something else remote with you guys. So we've been sort of thinking about the timing for that and the topic. And I know you've had a couple of really good events. You've had sort of like regional Scrum gatherings, and you've had I believe you had Dave Snowden over there as well, which was a massive coup for you guys. So yeah, look, hopefully I can follow up maybe some of what Dave talked about with with an equally interesting topic. So, look, I'm going to just talk about sort of technical debt. Now, technical debt's one of those things that lots of people sort of talk about in agile teams, but quite often you see a lot of teams don't really sort of give it any kind of structure and any kind of control and any kind of mechanism. They talk to it, but they don't try to sort of manage it and understand it and view it. So I'm just going to share some of my thoughts here sort of around that. So let me move this out of the way. So some of you may have seen this. This is something, so Martin Fowler came up with this concept called the design stamina hypothesis. And basically, the line there is how much value we've sort of delivered, how many features we potentially deliver over time. And we've got two approaches for this. We can take the just ship it approach, where we just start working on new features, new capabilities, and we just keep releasing those into production, and we just keep adding on top of them and adding on top of them. Look, and that's great in the early days of projects because we want to prove certain hypotheses, or we maybe want to prove architecture. We want to prove that the solution we're trying to build is valuable. But the danger we've got there is that as we just keep adding that code, we start to accumulate technical debt very quickly. And that technical debt then slows down our ability to add new features. Now, the opposite approach to that is we do a big upfront design where we don't really think about shipping any code. We create, we really understand how components are going to interact, what that looks like, how we're going to think about scalability, how we're going to think about performance, all of those non-functionals, all of those sort of design aspects. We get all of that fully understood. Now, obviously, the challenge there is that we don't deliver value to our user. So, our users tend to get a bit miffed. So there's some point within this model where we have this design payoff line. So doing upfront design, and look, and obviously the green one would eventually sort of, it wouldn't keep going incrementally. I just haven't drawn the grass very well. But it would sort of flatten off or at least slow down. There's some point in time where we have this sort of design payoff where doing that big upfront design actually pays us benefit. But we've got to marry that with giving our customers some value. So
Andy, you're on mute.
I don't know what I did then. Don't know what I did. So look, what we've then potentially got is, look at this, within this sort of model, as we're sort of in this space here, so our velocity of delivering increased value starts to slow down. I sort of think of that as my refactor zone. So that's when we should start to think about how do we refactor our solutions? Because what we basically want is we want the benefit of this, we want the benefit of design, but we want early delivery. So, and look, and this is not 20% into the project. It's not 50% into the project. It's a conceptual model. It's a sort of hypothesis type model. But at some point during our delivery, we're going to enter this refactor zone. And that's where we should sort of think about, well, okay, what tech debt have we accumulated? How are we going to start to sort of pay that tech debt down? How are we going to start to improve our architecture? How are we going to sort of, create a good emergent design that doesn't lead us to sort of this plateau of bad design? Now, one of the challenges quite often that we have when we when we're talking about technical debt as development teams is, how do we get our product owner to understand the concept? How do we get our business users to understand the concept? Because obviously, you know, they just want value. No, just give me features, give me features, give me features. Don't work on this, you know, refactoring. Don't work on technical debt. I don't understand that. So we've got to come up with a mechanism that that helps them to understand why sort of refactoring and management and control of our tech debt is sort of valuable. So look, there's this sort of simple, just this simple sort of view that we can take. Look, for any sort of delta F, i.e. increase in functionality or increase in features, if we have a good design, then that delta time to deliver that delta F is quite small. But if we've got bad architecture, bad design, lots of technical debt, then that capability to sort of increase our scope eventually gets longer and longer and longer and longer. So we can have that sort of conversation that, look, delta T for good design can be significantly more than sort of delta T where we don't have good design. So, you know, it's just a sort of simple way that we can have that conversation with our business stakeholders. So that's the essence of the sort of the design stamina hypothesis that Martin Fowler sort of talks about, that we need to find that sweet spot. We need to find that position where we're going to start to think about refactoring. My view is, look, we don't necessarily have to think about refactor straight away, right? If we just want to get a proof of concept out there, we want to get some early value, I think it's okay to deliver that rapidly and in care technical debt. Technical debt's one of these things that people get fearful of it. They sort of, oh, tech debt is bad. But it is a fantastic metaphor, just like financial debt. You know, a lot of us probably leverage sort of financial debt in our day-to-day lives. If we've got mortgages, or, you know, if we use credit cards to buy flights or book holidays or anything like that, we all leverage financial debt and we don't think anything of it. It becomes a challenge when we have too much financial debt. And technical debt's exactly the same. If we use it judiciously and we use it in the right way, it can actually enable us to very quickly deliver some quick capabilities and some quick wins for our customers. And that's what we sort of talk about in this sort of early stage. So my view is, don't worry about perfect architectures early on, because we'll come to this point where we can start to think about refactoring and then benefit from this sort of, you know, good design sort of model here. So what we'll get is this sort of S-curve, where this will then start to sort of, you know, come up as we refactor and we factor in good design aspects. Okay, so that's just a bit about some sort of conceptual stuff around debt and why. Now, Martin Fowler also talks about technical debt has these 4 quadrants. So not all debt is the same. So he has these sort of 2 axes where we have prudent debt, we have reckless debt, we have deliberate debt, and we have inadvertent debt. And then, you know, we have these sort of zones. So we have prudent and deliberate. And this is classified by the sort of mindset of, look, just ship it now and we'll deal with the consequences later. So, you know, this is this sort of type zone here. There's the reckless deliberate. So, you know, this is where maybe we're under pressure from business stakeholders. They want us to do a release. We know we're not ready, but we release it anyway. That's reckless, but we do it deliberately because the business is pushing us. So, look, we don't have time for design. That's the sort of classification, and that's the sort of mindset that we're into when we're in that reckless, deliberate sort of quadrant. There's also reckless inadvertent, where, well, we just don't know any better. And this might be classified by, well, that's the best way to build it, right? You know, we're just not maybe up to date with some of the latest patterns, some of the latest sort of frameworks and additional tools that might help us to sort of build things. And then lastly, we've got this sort of prudent inadvertent, where we do something and then we realize, look, with hindsight, we should probably have built that differently. So we've got these sort of 4 lenses that we can think about with sort of technical debt. Now, one thing that I would sort of suggest if you're struggling with technical debt in your projects already is run a workshop with your teams. Just create a poster, a simple poster like this, and just get the teams to start to create a post-it and stick that post-it within the relevant quadrant. And it helps us to understand, well, how did that debt exist? How did it sort of come into being? And potentially then give us a strategy for how we're going to deal with that. So it's a really useful way to get a good understanding of the debt that's emerged sort of in your solution, thinking about it in those 4 lenses. So, look, I mean, really quickly, so deliberate, prudent. Look, this is, a little misunderstood. So don't put items in here just because the stakeholder's pressuring you, right? That's deliberate, reckless. This quadrant is for genuine items where we must ship something because the business has a compelling ROI. So, maybe the business is actually at threat of going out of business if we don't create a release. Maybe there's a business opportunity that's not going to be around for very long. Maybe our competitor's about to launch and it will completely close us. Maybe there's a trade show and we have to have a product ready. So that's an example of sort of, deliberate prudent, where we make that deliberate decision that we're going to do something. We know we're incurring debt, but there's a rationale reason for it. So don't mistake that one with the situation where we ship because we're being pressured. Where we're being pressured, that is deliberate reckless. We know it's bad. It's bad, but we're doing it anyway. There's then the sort of prudent inadvertent. Look, this is the one that generally occurs sort of all the time, right? Hindsight is a wonderful thing. So this could be new emergent technologies, might improve how we would build that solution or how we might architect our solution. What it basically means is, look, we shouldn't spend a huge amount of time trying to predict the future. Just focus on the value. Do things like test-driven development, red-green refactoring. Think about sort of emergent architecture and think about sort of, code inspections, adaptation. Those are some of the ways that we can at least remove some of the inadvertent debt and some of the reckless debt that might creep in, so that at least we're controlling the prudent inadvertent. Then we've got the deliberate reckless. Look, this is essentially indicative of a poor process. Nobody should really deliberately create reckless debt. So it just means that we're cutting corners. There's no real clear business justification for doing what we're doing. So we're rushing a delivery because of the projects are in the pipeline and the team is needed, or we're rushing delivery because somebody senior is measured on milestones, not necessarily on value. So we deliver it anyway just to satisfy that person. Or we're rushing just because of arbitrary dates where there's been no real conversation with the team about, well, okay, what is the impact of that? The iron triangle between the quality and the time sort of aspect of this. And then there's the final quadrant is the bottom left, which is essentially this is incompetence. So, we just don't know what we don't know. So we're actually, and this is one of the most dangerous ones because we don't know we're creating debt. So this is the one that we need to be really cautious of. We can improve this. So things like pair programming, things like test automation and code analysis tools can be great ways to sort of close the loop on this, this incompetence-driven sort of lens of technical debt. Maybe even things like training on new emergent technologies. So understand what our technical strategy is, and then train and develop things that are maybe outside of our core solution, little prototypes that we can understand how things hang together, so we're not recklessly creating sort of debt within our product. Okay, so we understand a bit about what technical debt is. We understand at a high level how to classify debt. We need to quantify it. So again, just like financial debt, technical debt has two elements. So there is the interest on that debt, and the interest on technical debt is the extra effort we spend working around that debt. And then, as with financial debt, we have the principal. And the principal would be the time taken to remove that debt completely. So I've got two little four little pieces of debt there. Item A, item B, item C, item D. The dark sort of gray-green color is the principal. The yellow is the interest. So if you had those four pieces of debt and understanding what the interest and the principal is, which one of those would you pay off first? I've given you an answer there, but does anybody know why it would be A? No? So the interest is actually quite high on A. We're spending, well, it's about 3 times as much. So we spend about 3 times of that, 3 times our time working around this technical debt every time we touch that piece of code. Whereas if we just actually fixed it, if we just made the change, it's about a third. So we should probably focus on this item first. Item B, the interest is relatively low. The time to fix it would be very big. So with this one, we probably just want to carry on working around it for the time being. Item C, again, the interest, the pain that it causes us is relatively little. So we would probably, again, ignore this one. We'd work around it. It's not huge to fix it, but it's also not a pain for us to actually work around. Item D is an interesting one. It's about the same. So if we didn't do A for whatever reason, we might think about doing D, because the pain that it causes us is about the same as what it would be to just fix it. So we should think about that when we sort of think about our technical debt. What is the ratio of the interest to the principal? And look, and again, we don't have to have hugely accurate numbers for this in a similar way that we do story point sizing. We could do some planning poker around this. Okay, what's the interest, and just play some planning poker. What do we think the principal would be, and play some planning poker, and just get those 2 sizes, and then use that to sort of evaluate which one you might sort of think about paying down first. But then what if I said to you in that previous example, item A, we only touch that piece of code once every 6 months. But item D, in that same amount of time, in 6 months, we'd actually touch item D 10 times. Then suddenly the interest on A, while it's quite big, it pales into insignificant when we compare it to D, because we're always in that bit of code that is D. So in this instance, we might then think about D instead. So think also about the touch time, how many times we actually are in that piece of code. If it's a financial year-end piece of code and we're only in it for once a year while we do some tweaks and some updates, well, look, maybe it's not that critical to us. Whereas if it's a month-end procedure where we're doing that 12 times a year and then we've got some debt in that area, then we might want to think about the month-end before we think about the year-end. So again, think about those sort of touch points. And in that instance, well, look, maybe here D becomes the most important one to think about. Does that make sense to everybody? Those 2 different sort of lenses. Yeah. Yep. Okay. Yep. Any questions so far?
I'm good.
No, all good. Okay. Now that's all well and good, but quite often we have to think about technical debt has a strategic element to it as well. So this is the organizational aspect of the piece of code that we're working on. So if we, again, let's think about those 4 pieces of technical debt that we had. Maybe item A is in an application that generates $40 million worth of revenue every year, whereas application D is only in a domain that generates 7 million. Now, in that instance, look, maybe here again, then we're suddenly back to item A again. So we only touch it once a year, but look, it's business critical. It generates our a significant amount of value for our organization. So suddenly we might be thinking backwards again, and we might think, actually, item A is the area that we need to sort of think about. Now, again, this is useful if we're having that conversation with our product owners about, look, our technical debt's getting a bit out of control. We're at that sort of curve of our debt stamina hypothesis, and we're slowing down our ability to generate code. We want to fix some of this. So if we're working on a portfolio, we might then have that conversation. We're going to spend 2 or 3 sprints paying down some technical debt. We think we should do it in application A, because that's the one that's our sort of cash cow. So suddenly we flipped back to item A again, potentially. So look, there's different things that we need to think about when we're sort of measuring technical debt. There's the principle. So how much time would it cost me to just fix this, to just address it? How much time am I spending working around that every time I touch the code? How much pain does it cause me? How many defects does it generate? How much data corruption might it cause if we just sort of work around that? There's the frequency with which we touch that piece of code. That's the other lens that we think about. And then there's that sort of strategic sort of value of the domain that this application actually exists in, and what's the strategic relevance of that to our organization. Okay. So there's also now, I guess, and this is similar, but there's that portfolio lens. So we've got a couple of development teams. Maybe they work across a number of different solutions within a portfolio. So we've got this sort of lens here. So the degree to which the application currently provides value to the business. So again, low to high. There's the degree to which the application fulfills any future needs of the business. Again, sort of low to high. And we've got this sort of quadrant. So if it doesn't provide much future need, and it doesn't provide immediate value, it's an application from a portfolio perspective that, look, this is just a dog. So it doesn't really provide any immediate value now. It doesn't contribute value to our organization into the future. So if we've got technical debt in this application, look, and we've got time available, we're not really going to gain a lot by paying down some of that technical debt. So the approach here would be, look, just leave it. Just let it live. Let it sort of continue to do what it needs to do. We might do break fix where that break fix is critical, but we wouldn't necessarily think about significantly re-architecting an application that sits within this domain. We've obviously got our sort of cash cow. So this might be systems that are legacy systems. So if we're working in the financial, I read a fantastic article the other day. It was saying, I think it's something like 40% of the world's bank clearing transactions are still processed through COBOL systems. So, a language created, 60 years ago, in the 1960s. 40% of our global transactions are still, handled in that. That's probably a great example of something that's a cash cow. It doesn't necessarily fulfill our future need for the organization, but look, it's mission critical. It provides immediate value to us now. So look, this is really high value to us now, but it doesn't necessarily support our long-term vision. So within this, look, if we've got technical debt, the approach here might just be, right, let's do the minimum to maintain operations. So, we're not necessarily going to significantly re-architect this, but if we've got an old framework that's going out of support, it's going to be deprecated. We might want to think about maybe changing that. So we do the absolute minimum just to keep this thing ticking over, because it is high value to us. So if it breaks, then we create a significant problem for the organization. We've then got our prodigies. So this is applications that are the future of the business. So these are providing our sort of strategic alignment long into the future. They're maybe not that valuable now. Maybe they're still on sort of, they're still emergent. They don't particularly have a huge market, maybe, or for whatever other reason, they don't provide value now, but this is the future of the business. So with these, what we should be looking at is prevention. So really good practices like test-driven development, like red-green refactoring, so that any kind of technical debt, it's almost minimized as soon as it's created. Again, code profiling tools could be a really useful thing in this area as well. And we can set some thresholds. So, if our code quality score based on a code profiling tool is above a certain score, then we're going to just spend some time sort of paying down our sprints, paying down some technical debt. So it's really important in this domain that we prevent that technical debt arriving in the first place, because that's what's going to potentially put this at risk for the long-term sort of strategic vision for the business. And then we have our stars. So these are things that are, rapidly emerging sort of solutions. They're delivering high value to us now, but they're also providing that long-term sort of strategic alignment. So these are the ones that we want to think about fixing that debt, fix it as soon as we understand it. So these are relatively old applications, well, not necessarily old applications, but they're applications that have already been built. They're in high usage, they're generating high volume, they're generating high value. So it might be a bit too late to do the prevent approach with these. So these are the ones where we think about, okay, how are we going to fix this? How are we going to address it? Let's use some of the strategies that we've talked about to measure its principle, measure its interest, measure the touch times, measure the strategic value of the solutions within this portfolio. So again, a really useful way to sort of think about how we can use portfolio level prioritization. So think about the different areas within the organization where we would pay down technical debt. Okay. Any questions? Any observations? Anybody? So how are people sort of dealing with this at the moment within the group?
Maybe not particular on technical debt, but I think the day-to-day decision making has a lot to do with either this one or the Eisenhower matrix as well, right? They have us to prioritize actions that could turn into not just business value, or probably just ROI sometimes. Yeah. So I like it.
Yeah. This is a variation of that sort of Eisenhower matrix in it, just with the quadrant sort of classified. Yeah. Anybody else?
That sounds very similar to project portfolio management. I mean, the way to look at it. It's very interesting. I had one question: is that how do you uncover most of the technical debt? Is that because it's, I mean, I've been on some project where, I mean, the big item were easy to identify, like a platform that is no longer supported by a vendor, or the technology is obsolete. So the big ones are, I mean, the easy one. But some of them is actually is deep into the code, and they are not that visible actually.
Yeah, absolutely. Look, and this, what you're talking about there is this quadrant here, where, look, we just don't know any better, or as you say, look, maybe it's an old framework we don't know exists. This is the sort of difficult one, because, as you say, it's hard to measure what we can't see. So I think this is why it can be really useful to run an exercise like this, to just get the team sort of thinking about it. Look, we'll get lots of post-its in this area. Oh yeah, look, we designed it this way because the managing director told us we had to ship it, and so we might have some tickets here. Oh yeah, we released that one because we had that show coming up, and oh yeah, the junior built this one, and we didn't know any better at the time, right? So we can probably quite often fill in lots of this one. This is the one that quite often gets ignored, right? Unless we've actually maybe gone through code. So again, things like code profilers, code quality profilers can be useful in this space. They might help to identify things that we aren't aware of as humans. So things like, SonarQube, run SonarQube against your code base, set some thresholds, set some rules, set some standards, and where it sort of comes up with some bad practice, highlight that and record that as technical debt, because that's what it is. So that can be a sort of really useful way. But I do find that sort of workshops with developers are a really good way. So if you're working with a team that has maybe just ignored technical debt, we've got a system, we don't really know what's there, we want to get on top of it, we want to control it. Well, the first thing is to identify it. So we have to run some kind of workshop that, and again, just bring all the developers in a room, give them some posties, give them a Sharpie, and just say, just get them to create what they think exists as technical debt. It can be useful to look through the code, look through maybe your defect management system, because if we have an area of the code that tends to throw up lots of defects, quite often that's a pointer to an area that has maybe got elements of technical debt in it. We might have things where, we've hard coded certain values instead of making them sort of variables or items that are generated from a config file or from a database sort of table or something like that. And again, they can be relatively easy to find. So again, we can do code searches to say, well, okay, look for any values that are sort of set as hard values instead of reading from a database. But unfortunately, there is no solution other than just a bit of upfront, let's just guess it. Let's just try and workshop it. Now, you won't get everything, right? So don't try to sort of approach a workshop and say, right, we're going to figure out all of our debt. You won't. You might figure out 80% of it. Or you might figure out 20%, sorry, that is the 20% that causes you the 80% of your pain. So the Pareto principle. And then once you've got that baseline, as you uncover new things, just make sure you record them. So it then becomes a continuous activity of keeping on top of where your technical debt is. Now, that was the sort of next piece that I was sort of going to touch on. So, look, I mean, we can't manage what we don't measure. So, and again, right, it doesn't have to be anything particularly fancy. So just a simple chart over time. So what's our debt level? We could, this could be the number of items. It could be story points to solve that debt. It could be, it could be days. If we're in an environment where we estimate in days, well, it might be the number of days to fix that debt. So that's that sort of axis. And then over time, as we uncover new things or where we create new debt and we do it prudently, if we create prudent inadvertent debt, then we know it exists. We might want to record that in our system. So what we have over time is, just a chart that starts to do sort of something like this. And then just as a team agree, okay, what are we comfortable with? So have an upper limit and a lower limit, a threshold. And then as soon as your technical debt hits that upper limit, have the conversation with your product owners, have the conversation with your business stakeholders and say, look, we're at that point now where we're uncomfortable with the level of technical debt that we've got in our solution. It's starting to cause us problems adding new features. So we want to spend a bit of time paying that debt down. So for the next 2, 3, 4, 5 sprints or whatever it needs to be, we're going to focus on removing some of that technical debt. So we start to see something like this. And we carry on working on it until we hit a lower threshold. And then once we're at the lower threshold again, everything's back to normal. We can start, hopefully we've got a reasonably architected solution. We can start to work on value again. So look, this doesn't have to be sophisticated. You might just have hashtags in your code that every time a developer purposely create some technical debt, he does so, prudently. Maybe he just puts a label, hash debt. I'm going to fix this later. I know it exists. And in my comments, I'm just going to put hash debt. And then we can just do a count across code. How many hash debts do we have? 10, 50, 1,000. We've now got a number. It might be every time we identify a piece of debt, we just create a story, a user story, a user task in Jira or ADO or whatever system we're using. But we have a measure. We have something that is telling us how much debt we've got and specifically what some of that debt is. And again, if we're doing story points, well, again, this axis here might be story points of the debt. Now, one thing that I quite often do with teams, just because it's really easy, is so I create an epic, and I call that epic technical debt. And then I create user stories for every time we uncover debt, and we assign that user story to the epic. So we create that sort of hierarchy from epic to story. Now, I know that's sort of, not the true definition of an epic, and it's not the true definition of a story. But to me, epics and stories are things that deliver value. Now, value could be knowledge value as well as business value. And to me, knowing and understanding my technical debt is good knowledge value. So I think, using those sort of hierarchies is still, it's not breaking the rules, right? Scrum doesn't say what a user story has to be. Scrum doesn't even say we have to have user stories. It just talks about product backlog items. So look, maybe those product backlog items could be items of technical debt. Now, the beauty of doing this is that we get this out of the box with something like Jira. If we then use an epic burn-up chart, Jira will tell us how much debt, and we can see that debt rising over time. And then when we start to close off some of the stories, we can see that coming back down again. So this can be a really easy chart that we can generate really, really, really quickly. And again, if we've got an information radiator, we've got burn-up charts on the wall for the sprint, we've got, maybe some wireframes that show, what the screens are looking like, maybe a list of user stories, maybe our roadmap. Put your technical debt map up there as well. It's front and center, then everybody can see this. So again, we can then really start to have a robust conversation around the level of debt that we've got. What is that? What is that now looking like? Are we approaching this sort of upper threshold? And if we are, then look, we need to spend some time paying that down. Now, you won't know what this is to start with, right? This is going to be in a good agile mindset. This will just be inspection and adaptation. You might set a limit to start with, and then you will work towards that. And if you find that actually we did that too early, well, maybe up the limit. Maybe we accumulated too much debt and it was actually too painful. So set that limit slightly lower. So find what that level is over a period of time through a bit of inspection and adaptation. But once you've got it, try to bake it in so that, again, everybody's clear on what is our comfortable level of technical debt that we're going to deal with. Okay. That's me all done. Maybe slightly shorter than the Team Topologies one. I think we've been about 40 minutes, but questions, observations, what discussions, what are we thinking?
Thank you, Andy. Any questions, Andy?
Yeah, some comments. So the idea effectively to create epics and user story has the advantage to make this technical debt visible to the whole team. So that everybody is aware that it exists and that at some point of time, this will need to be addressed.
Is that something you do already? Do you do anything like this, any kind of measurement of your debt?
So not at the moment, but I had an engagement with a customer where effectively the challenge was there was a team who was purely focusing on new functionality and completely ignoring tech dev. Yeah. And then there was the architect who was actually more thinking forward. They was thinking about in the next 6 months, next 12 months. and he had the visibility of what would need to be refactored. And the challenge was the communications between the architect and the rest of the team. Yeah. And because they were not, at that time, they were not using epics and user story to show this technical debt.
Yeah. Look, as I say, I mean, technical debt on its at its simplistic level is not a bad thing, right? We shouldn't have this mindset that technical debt is bad, right? If we use it in the right way, like financial debt, right? If we need to release something early to get some business value from it, then that's okay to incur some technical debt in doing that, as long as we know what's there, as long as it's in that sort of prudent domain. We know we're doing it. We know the reason we're doing it is to get some early feedback and to deliver some value to our customer. Well, that's a good thing, right? Because we're here to deliver value, right? So again, right, it comes back to that design stamina hypothesis. Yes, we could spend lots and lots and lots of time creating the perfect architecture. Our users are not going to be very happy because we're not delivering new features to them. So we need to find the sweet spot. We need to deliver something and not be scared of debt. Debt's only bad when it gets out of control and we don't know it exists. We don't know where it's going to come from. We don't know when it's going to bite us. That's when it becomes a problem. Anybody else? Anybody else sort of have any strategies for sort of dealing with tech debt? You're all quiet this evening.
I guess I have a question. I think whatever you've shared is more like you have certain criteria which you use to assess how to prioritize your tech debt. But I'm wondering, when it comes to management being involved perhaps in the prioritizations, how do you deal with that? If say they have something else that they really want to prioritize, but it doesn't really make sense to you. So how do you deal with that?
Yeah. Look, I mean, I think, Lynn, it comes back to probably this one here. So we've got different, we've got a number of applications within our portfolio. We're going to have different levels of technical debt within those suites of application. It comes back to the strategic value of those applications. So, if we can get the business to understand that, look, we have to pay back some technical debt. Technical debt slows us down. The longer and longer and longer we leave technical debt, the slower and slower and slower we get. Get them to understand that first of all, right? And they probably see that. They see that, we deliver code quickly up front, and then we start to slow down as we get more defects and we get, upgrades to frameworks, and we start to do all of those things. They start to see that. So hopefully we can have that reasonable conversation. And then when we've got them to buy into that idea, it's then, well, okay, what's the strategic value of the different applications within our portfolio? Where do we want to focus our time in paying down our technical debt? I mean, in this example, look, if this application here has some technical debt, it's limping along. We know we might want to fix this, but this is the one that's got loads of debt. Well, this is the one that we're going to spend our time on, because this is worth $40 million to us, whereas this one's only worth $7 million. So again, think about the strategic value of the applications or the portfolios of applications that we're working on. Our goal here is to deliver value to the organization, right? That's the reason an IT function exists. So we shouldn't necessarily be wasting our time in this domain if we know we've got pain here. We should be able to have a good conversation with the business to say, look, this is the one where we should be spending our time thinking about that, that paying down of that technical debt, that increase of that value from that particular application domain. Does that make sense, Lynn?
Yeah, it does.
Yeah.
Thank you.
Thanks, Lynn.
I say it comes back to these 4 measures here. Think about this when you're trying to sort of assess the technical debt that you've got. What's the principle? How much would it how much time would I need to spend just to fix this? How much time do I need to spend every time I touch that code working around it, or fixing defects, or fixing data because it maybe keeps messing up some data? How often am I touching that piece of code? Is it once a year? Is it once a month? And again, what is the strategic value of the application that has the technical debt within it? So use all of those to create some kind of sort of view of your prioritizations. Now, that's not to say that sometimes, application domain D, it might be running on an old framework that is going to be deprecated, completely deprecated, and will not work. Well, in that instance, maybe, look, we have to focus on this one because we don't want to write off $7 million because this application will stop working maybe if we don't address a piece of tech debt or we don't upgrade a particular framework. So it's not always just about the biggest, but often this is the one where we should be spending our time. If we can keep this one ticking along, i.e. in this sort of area here, it's a cash cow. If we can maintain it, that's what we should be doing. But we should be focusing on our stars and our prodigies, these things here in this domain. Any other questions? Any other discussions? I'm curious to sort of understand maybe anybody using things like code profilers and using that to maybe identify what code quality looks like. Yeah, you using something like that, Victor? You and your teams?
Yes, a variety of them in the past, usually developed in-house.
Yeah.
So that's particularly important in the circuit design industry because of all the linting that's required for, what would you say? So you don't generate loose wires. So
yeah. Okay. Yeah. Yeah.
But yes, code profiling I think is really helpful. Even perhaps extending, what would you say? The ability to detect certain patterns that should be in certain code bases, and then extend that pattern detection to the wider code base, I found to be quite valuable.
Yeah, there's lots of really good design patterns and things out there, and a lot of good code profilers will point you to those patterns. So if you've built a piece of code and it doesn't necessarily sort of meet some of those standards, it might be difficult to read, it might be difficult to maintain, it might not handle particular error scenarios very well. That's great examples of debt. And if a code profiler can tell you that, now you don't have to necessarily fix it. I'm not saying you have to fix it, but you're now aware of it. You can now create a user story or whatever other mechanism you've got to then start to track that. Just write some hash debts in the bit of code then in that place, and a comment to say what the code is, or whatever your mechanism is. They are incredibly powerful, and lots of organizations don't really use them. I don't know if it's a bit of a developer ego thing that they don't want a machine to sort of tell them what good code looks like. But look, I think if they help you to write better code and more robust code, I think that's a good thing.
Yes, I suspect with the advent of generative AI, that's somewhat inevitable.
Yes, yeah.
I mean,
that's one of the dangers, isn't it? Now, yeah, generative AI has sort of shifted the goalposts somewhat.
yes.
Because anybody can write some code now potentially. Yeah.
Well, I think particularly what you described about the social technology aspect, right? About, for example, inserting hashtags or just perhaps TDD or even swarming around the code can be helpful in lowering the perhaps the access for the inadvertent quadrants. I think that I think is, again, age-old practices by now, but still incredibly helpful.
Yeah, this sort of prudent inadvertent. So, the wonderful thing about hindsight. Well, yeah, look, if this is the things that might emerge that we don't know about, well, let's put as many tools in place as we can that maybe try to minimize that. So yeah, things like TDD, red-green refactoring. Does everybody know what red-green refactoring is, by the way? I've sort of used it in there. Basically, red-green refactoring is you write your test first. Your test fails, so it's red. You write just enough code to make that test go green, to pass. Now, that code might not be very pretty. You've literally just knocked some code out to make the test pass, and then you refactor that code again to follow good practices, to follow the right patterns, to follow maybe any coding standards that your organization uses, any naming conventions or anything like that. That's then the refactor part. So again, just having that focus on using ideas like that can be a great way to not get rid of. You'll never get rid of prudent inadvertent, but it can at least help to highlight some things that you might not otherwise see that then might come and bite you in a year's time, 18 months' time. You've deployed that piece of code, you've forgotten about it, and then suddenly something that you forgot about comes back to bite you, and it starts messing up data because there's an error condition that you didn't think of, and you've then got 9 months worth of data that it's slowly in the background just been messing up, and you've now got to go back and fix it. And yeah, so anything like that can help us to try to minimize that is a good thing.
Yes. By definition, inadvertent means inadvertent, right?
Yes. Yeah.
So,
we don't know it's there. It's look, and I say, I mean, it does come back to this sort of deliberate, and again, this comes back to this thing of tech debt is not necessarily bad, right? We can make deliberate decisions to ship something that we know is suboptimal because we know we're going to deal with it later.
yes.
But we know that exists. So again, record it. Whatever your system is, record it. A hashtag in the code, a user story, whatever mechanism you're going to use, a Jira, a post-it on the wall, whatever your mechanism is, just make sure you record it so you don't forget about it.
Yes. Great guidance. Thanks, Andy. I'm conscious of time. We have 5 minutes left to this meetup. So if anyone have any questions or more questions for Andy, please feel free to ask away.
Or a quiet bunch tonight, Victor, maybe because there's no free pizza.
Oh, yes. We usually encourage the folks joining online to try to turn on their cameras, so it'll be somewhat more engaging. But it's been difficult to do that, I've learned, because since Singapore's reopened up, people are often commuting during the time of the meetup. So
yeah,
that's been a challenge. But yes, any questions? Hey. Hello, Gonzag. Sorry if I pronounce your name. Gonzague?
No, just putting my camera. Gonzag. My name is Gonzag.
Yes.
So just to share my experience, one of the challenges that I had in one of the projects is, so I was engaged with a company that was doing the development of the software, and the end customer only wanted the feature and didn't want to hear about refactoring. And every time we mentioned this, this was more like, oh, you should have thought about this the first time. You write crappy code. That was a comment. And so there was a lot of discussions about, yeah, now we designed this for 1,000 transactions a day, and now you are 1 million a day. It's a different type of system and architecture required to do this.
Yeah.
But this was a real challenge in the way that they engage on a fixed cost, fixed scope, and internally we had to design and to have an idea. Okay, how are we going to actually accommodate and find some budgets to do this refactoring? Because this was a long-term customer.
Yeah.
So it was a real challenge.
Yeah. Yeah, look, I mean, there can be commercial challenges definitely in that sort of space, especially if you're doing a fixed price sort of contract for a client, then yeah, it's a whole different sort of conversation, is it? And it's a conversation that the development team needs to manage internally. Then they need to be aware of that sort of design stamina hypothesis of, okay, when are we getting slower? We need to factor that into our estimates. Look, we want to deliver something quickly. We want to give this customer trust that we know what we're doing. So we want to ship something, but we want to be aware that we're not suddenly biting ourselves in the, in the foot just to meet that. So yeah, what's the fine line that we're going to tread? Because yeah, look, I mean, we could just do it as a waterfall type project, a big upfront design project, right? That's the safest thing to do. Might not necessarily the best from a commercial perspective for reputation or whatever reason. Any other observations from anybody else? That's a really good sort of story that comes out.
Well, we had a message in the chat asking if you could recommend books or resources on tackling technical debt. So if
that's a good one. Look, I mean, Martin Fowler, definitely look up some of his articles on the sort of design stamina hypothesis. Look, I think one of the good things is prevention. And I really like Dave Farley. So Dave Farley talks a lot about sort of technical aspects of development. So he talks about test-driven development. He talks about continuous integration, continuous delivery. And again, if we have that technical excellence, I think that can help to sort of reduce the amount of debt we create. I don't know that I've ever come across a book that is specifically about technical debt. There are books around sort of technical excellence and things like that, and that's probably what I would point people towards. Dave Farley also has some really good YouTube videos. So yeah, look, I would probably recommend that as a. I'll quickly sort of pop that into the chat.
Yes, that would be great. Thank you.
Dave Farley.
Mm-hmm. Yeah. So we are at the end of the meetup. Again, thank you, Andy, for making time to meet with us again. A second time this year, this time online.
Yes.
And I think particularly on this topic of technical debt, we've not had enough people speak to the developer perspectives. So this has been incredibly helpful and valuable. Thank you again. And we hope to host this session on YouTube as well, so stay tuned. I'll drop a note on our meetup announcement. But yeah, with that, thanks everyone for making time to attend today's meetup, and we hope to see you again soon.
Fantastic. Thanks, everybody. And maybe we'll think about another session that I can run in sometime next year.
Absolutely.
Brilliant. Cheers, everybody. Bye.
Bye.
Bye.